This project was inspired by Brendan Harris's model. Remember, he presented that, the Meccano one, and he said at the end of it he'd like to see one done in 00 gauge. So I decided to have a look at it for my grandson's model railway. So to get dimensions and how it would look, I looked up the internet and found examples you see there on the right hand side of typical scissor lifts, and they vary tremendously in size. So I picked one which was reasonably large. So to do the mechanical design, and again I did this on Tinkercad and printed the parts, and then the major problem was trying to understand how to make the whole thing lift and go back down again. So this here on the right hand side is the first prototype I made. Basically printed all the parts and then assembled it just using some small 2mm watch screws, and trying to understand how the whole thing worked. And things I noticed while doing it was the weight of the screws themselves added quite a lot to what you're trying to lift up and down. And the hole sizes depend how you printed the plastics, varied a little bit. And because of the scale, the cage at the top was actually quite fragile. And then at the very bottom where the chassis is to try and fit a servo motor in there and have the mechanics to lift and raise the scissor lift. And also what force would you actually need to get that off the ground and up. So there was quite a lot to try and solve. Replacing the screws, I had a look at a couple of things. One was just the hollow 2mm brass, just put it in the holes, and that worked not too bad, but it was quite difficult to swage over the ends. And another thing I found on the internet was these 2mm diameter rivets. They're hollow at the end, so they were ideal. They could be pushed in and you just hit the end with a small punch and swaged them out. And the holes, after I printed them, I just used a 2mm reamer, and that took any small pieces of plastic which were stuck in there, and that did quite a good job as well. And the cage in the top, because I broke a couple after I printed, I just increased the sections where the different parts came together, and it became a bit more robust. Method of raising it, I was wanting to try and keep it compact, and I found these small motors on the internet, and the idea was to work it like a typical scissor jack you'd have for a car. The only thing was it took quite a lot of power to raise it. This is the first attempt or second attempt at doing it, where you just the motor drives the lead screw, and it would raise it to sufficient height and lower it again. The timing was everything was quite good. But the only problem was once you actually loaded the whole thing up with the whole scissor lift and it was sitting at the bottom, it didn't really work. So it was back to the drawing board, or I could have looked at a larger motor, you know, your Crocodile Dundee approach. That's not a knife, this is a knife, but really, it was really just too large. It would be difficult to conceal, and I think it would just waste the whole thing. So it was back to the drawing board, and what I decided was just to use our bog standard micro servo motor and just use a lever to push it up and back down again. The idea of this unit is it doesn't have to be permanently fitted to a layout. Because it was going to my grandson's layout, I wanted to try and keep it all self-contained so he could just place it where he wants it and use it. So that's why here I've got the scissor lift at the top there, and then the motor is here. You could actually have it underneath and pushing up, as you probably do in other models. And the first linkage I had in there was just really a paper clip, bent it round about, put it in place. But I found that the paper clip, I couldn't bend it accurate enough, and you were losing height trying to lift it up and down. So I just made another moulding which would fit on there, and that kept it more it didn't get so much play in it. So this is how it now looks. You can see there the scissor lift on the left-hand side, and then on the right is the motor, so it just moves 90 degrees and it lifts it up that height. The problems here, as you see, is because the guy doesn't have his high-vis vest, and he doesn't have the harness and clipping all that onto it, so it could be enhanced to be more up to date if you wanted to. And this is just showing it in a typical application where the house hides the motor and everything else is to the front. I found if I printed things in black in the centre there, it's more difficult to see the mechanism, so it hides it a little. That's it down. Now, these are all the parts, the 3D printed for it, all the chassis and the bit at the top, and the wheels and the linkages and the part for holding everything together at the bottom. The only other parts that they make was top and bottom. There was a little guide pin just fitted into some slots, and I just made them from a round nail, cut it, just filed it down, placed it in, and then the motor connecting to the linkage from the two horns, it just turned up a piece of plastic. Now that could be changed. You could make that just a screw or move the motor closer together and link them together. Assembling it was quite simple. You just press these in and the wheels all was fine, and the same for the linkages. There, I just put the rivets in, swage them over slightly, and then the guide pins go top and bottom. It just all fits together quite neatly. Now, for working the servo motor, I just decided to try and keep it as simple as I can, and I just used a standard control, the circuit you get for controlling the servos for testing them. Just put that in a little box and powered it from a USB cable. But the only thing I thought after I'd done that was that it's another cable having to lie about his layout and find somewhere to plug it in. So what I did was I added a piece onto the box here, you see on the left-hand side, just printed another one, and into that box I put a 9-volt rechargeable battery. So now, instead of having a cable lying about, it just has to find somewhere to put the small control box. And I also put a small DC to DC converter to take it from 9 volts down to the 4.5. And so it means now it can use it, and then it just has to use a USB cable to charge up the battery whenever it's required. So that's my grandson's got it on his layout, and he's got it sitting in a corner there, and he seems to be quite pleased with it. What I've sent Davey is a zip file with all the STL files, and also this PDF of all the parts listed that I used to make it up. So if anybody wants that, Davey can send it to them. They're welcome to have it if they want to take it and play around with it and modify it whatever way they want. It's also on Tinkercad. It's available to the public on Tinkercad for anybody else. And I see that was the box I was talking about.